Let's integrate this function. So just by looking at this immediately, I could tell that my numerator has a degree of 1, while my denominator has a degree of 2. So because my numerator has a smaller degree, than my denominator, that means I could use partial fraction decomposition. So to do that, I'll first start by factoring out my denominator. So I'd have x times x plus 2 dx. And to start decomposing, I will have some constant a over that first part of x plus some constant b over that second part of x plus 2 dx. And now I want to find my constants a and b, and to do that I'll condense this into one fraction by finding the common denominator between these two terms. So I have a times x plus 2 plus bx all over the same denominator, should not change. And I don't really care about the denominator at this point, just looking at that numerator. I have that, let me distribute this and I'll write it down here. ax plus 2a plus bx is all equal to my old numerator over here, my original numerator, so 2x plus 6. And now to find my constants a and b, I'll be creating a system of equations. So looking at any terms that have a degree of 1, which is ax and bx, and then on my right hand side I have that 2x, so I'll be setting all of those equal to each other, so a plus b is equal to 2. And then my degrees with my terms with the degree of 0, I have 2a and 6, so 2a is equal to 6. From that second equation, I could immediately find the value of a by just dividing by 2 on both sides. And I get that a is equal to 3. Now that I found a, I could immediately substitute this into the first equation. So b is going to be equal to 2 minus 3, which is negative 1. So I found my two constants. All I have to do now is just plug them back into my decomposed form. So I have a is 3 over x. And while I'm at it, I'll separate that into two integrals because I think that's easier to solve. And because my b is negative, I can take out that negative outside of the integral and I have 1 over x plus 2 dx. So the first integral is relatively simple to solve. If you take out that constant 3, if you take out that constant 3, then you just have 1 over x, which is just ln x. And then that second integral is a simple u substitution where you could set u is equal to x plus 2, du is going to be equal to dx. So very simple again, you end up with a log of x plus 2 plus an arbitrary constant c. Now this is a good enough answer, but we could clean things up a little bit, so I can start by using some log properties so that I could condense this into one log, so that 3 can be dragged up as an exponent, so that I have this can be rewritten as x cubed over x plus 2, all inside that natural log, plus an arbitrary constant c. And that's it.